Struggling in maths? Not clear in concepts? Then stay tuned to my channel Maths Made Easier. I've explained the concepts in a way everyone can easily understand. Here we can look into the number system.
What is number system? Let's look into the various types of numbers. In other words, we are going to see how we can name the different collection of numbers.
This shows the set classification of numbers. On top of the hierarchy are the real numbers. The real numbers are classified into the rational and the irrational numbers, the details of which we can see in the subsequent slides. As you can see, the rational numbers contains the integers. The integers in turn contains the entire set of whole numbers, and the whole numbers contains the entire set of natural numbers. We all know about the natural numbers, that it begins from the number 1 and it goes on till infinity. The whole number, on the other hand, it contains the entire set of natural numbers along with the number 0. The integers, on the other hand, it contains the entire set of whole numbers, meaning it has the numbers 0, 1, 2 and so on up to infinity, as well as the negative numbers like -1, -2, -3 till it reaches minus infinity.
The real numbers are classified into the rational and the irrational numbers. The rational numbers indicated by the alphabet Q. The definition goes like it comes under the format of P by Q, where Q is never equal to 0. Also, there is no common factor between P and Q other than 1. In other words, they can be called as the coprimes. But irrational numbers, on the other hand, the definition goes as it doesn't follow the format of P by Q. Apart from the rational numbers on the number line, there could be so many other numbers which are classified under the irrational numbers. A more specific definition of a rational number could be if a number is represented with the decimal expansion, and if the quotient is terminating, or if it is non-terminating but recurring, then we call that particular number as a rational number. On the other hand, when the decimal expansion, either if it does not terminate or if it doesn't recurrent, then it is called as an irrational number. We can further look into the details of each one of these with further examples.
Let me quickly throw some light on the difference between the rational and irrational numbers. The natural numbers, whole numbers and integers, they all can be represented in the format P by Q, where the denominator can take the value of 1 and hence they can be called as the rational numbers. If we look into the other fractions, we can discriminate between the rational and the irrational numbers. Say for example, you take a fraction 1 by 4. The value is 0.25. It is a terminating fraction. There could be other fractions where the value could be non-terminating, but it should be recurrent if it has to be a rational number. For example, 1 by 3, where the value of 1 by 3 is 0.333. It is a recurrent fraction. 1 by 7 is also a recurrent fraction. If you can look into the pattern of numbers where 1, 4, 2, 8, 5, 7 is repeating. The irrational numbers, on the other hand, if you consider the decimal value, it never stops. It is non-terminating and non-recurrent. So the values of perfect squares is 0, a rational number. Can you write it in the form P by Q and where Q is not equal to 0? 0 can be written as 0 by 1 or 0 by 2 or any other value in the place of the denominator. So, since it can be written in the format P by Q, we can say 0 is a rational number.
We need to find 6 rational numbers between 3 and 4. We simply have to rewrite 3 and 4 in terms of P by Q. And we need to find 6 such rational numbers between these two integers. So, we need to find 6. So we can choose any number which is greater than 6. I choose 7. I multiply 3 by 7 divided by 7, which gives 21 by 7. Similarly, when I multiply 4 by 7 by 7, I get 28 by 7. Now our task becomes very simple to find 6 rational numbers between 21 by 7 and 28 by 7 as 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7. These are the 6 rational numbers between 3 and 4. These are not the only 6 rational numbers. We can find other such combinations by multiplying by, say for example, 8 by 8 instead of 7 by 7. Even in that case, we can find 6 rational numbers lying between 3 and 4. The numbers given are 3 by 5 and 4 by 5. And we need to find 5 rational numbers between 3 by 5 and 4 by 5. Since it is a number 5, we should choose a number which is greater than 5. So here I am considering the number 6. I am finding an equivalent fraction of 3 by 5 by multiplying it by 6 by 6, giving rise to 18 by 30. Similarly, 4 by 5, I am finding it as an equivalent fraction by multiplying it by 6 by 6, giving rise to 24 by 30. Now it's very easy to find 5 rational numbers between these two fractions, namely 19 by 30, 20 by 30, 21 by 30, 22 by 30 and 23 by 30. State whether the following statements are true or false. Give reasons for your answers. Question number 1. Every natural number is a whole number. If we look at the natural numbers, they start from the number 1 to infinity, whereas the whole numbers, they begin from 0 to infinity. So we can very well understand that the entire set of natural numbers is contained within the whole number collection. So this above statement of every natural number is a whole number is true. Question number 2. Every integer is a whole number. As we all know, the integers contain 0, positive numbers and the equivalent negative numbers as well. But the whole numbers do not contain any of the negative numbers. So this statement is false. Every integer is a whole number. It is false. Every rational number is a whole number. When we take any whole number, say for example 5, we can rewrite the number 5 in terms of a rational number by satisfying the format of P by Q as 5 by 1. So, any whole number can be considered as a rational number, but the given question indicates that every rational number is a whole number. Take for example a rational number 512 divided by 34. It takes the form P by Q, so it is a rational number. It can never result in a whole number. So, not every rational number is a whole number. The above statement is false.